Hello, and welcome to Pursuing the Pulse. I'm Mark McCarthy. Today I'm here with Kate Radzwell and Aaron Opbroek with Resolution Medical as part of the concept development team. Kate, Aaron, good morning. Before we get started, why don't you tell us a little bit about yourselves?
Sure, Mark. Like you said, Kate Radzwell. I have been with Resolution for about 4 years. I originally started in the concept development group and then have since moved to our formal development as director of product development for our delivery systems.
Yeah, and I've been here for over 8 years now, and kind of the opposite path of Kate. I started in the formal development group for the majority of that 8 years, and more recently, Kate and I have switched roles, and that's kind of why you see both of us here today. And so I'm now leading the concept development group.
Wonderful. Let's get started. What types of customers are working with Resolution Medical?
So it can be a pretty wide variety, everything from grant-funded universities or doctors that are self-funded to startups that are looking for a specific expertise or a little bit more horsepower, and then also even large corporations that are looking to prototype more quickly and more efficiently.
And in terms of prototyping, what does the prototyping process look like?
Well, it really starts with understanding what your customer is looking for. Not every customer is looking for the same thing. Not all of them come in at the same point in the process. So some of them, we really want to sit down and have a brainstorming session or two. That could look like an hour meeting, a couple hour meetings, to kind of tease out questions that maybe they haven't thought about. We really want to understand, what does the first prototype need to be to achieve what they want, all the way down to iteration 3 or 4. A lot of times that first one can be, very crude. It might just be not something that looks really well, but performs perfectly. Or vice versa. It might just be something they need to put on a bench top in front of a key opinion leader. The actual functionality can be tuned later, but they want something that represents what the final device might be, just at least visually. And then from there, once we understand that, we want to know, basically, how do we test this? How do we know what's good? How do we know if we're meeting your requirements? And a lot of times, if you don't talk about those requirements up front, you kind of go down too wide of a path, too much ambiguity, and you could waste a lot of time and money doing that. So once we find out, okay, we're going to make these prototypes for you, how are we going to test them? How are we going to tell if it's good? And from there, we kind of go down the path of produce, iterate, test, and get feedback from the customer.
And what kind of time frame should be expected from this process?
Well, there's some flexibility to that. What we're lucky to have here at Resolution is a big warehouse of overrun materials, stuff we haven't used in the past. And for the concept development team, that works great because you don't necessarily need the traceability or even, use of expired materials is fine. We have a warehouse full of PBACs, full of heat shrink, full of mandrels, PTFE liners. And that, if you're able to use that and get close to what you're looking for on your first prototype, that really helps you go quick. We don't have to wait for 2 weeks, 4 weeks, or whatever for the extrusions to come in. Even much longer on mandrels and things like that, where you got to send them out for PTFE coating. So it could be anywhere from 2 to 4 weeks if we can control the materials in-house. And then, depending on the components and the industry lead times, it might be 4 to 8 weeks if we have to custom order materials.
So tell us some examples of how you take a design concept into a reality.
Yeah, so one of the stories we have from a while back, one of our probably more famous, maybe not famous is the word, but successful customers. I didn't live this firsthand, but the story goes that a customer had $7,500 and they came to Phil Harstead, who is the originator of the concept development group, formerly Harstead Engineering, and said, Phil, what can you do for $7,500? I've acquired this IP. It seems that there's something there, that, something that somebody's not pursuing. It's kind of stagnant IP. So he took that and he's like, kind of explains like, well, 7,500 is kind of low to achieve a prototype, but I think I can do it for somewhere close to that. So combination of just kind of finding cost-effective ways, what kind of clamps or molds are sitting around, and the story goes he was able to put together a clamshell mold around some impellers, some wireframe impellers, and put a skim coat of polyurethane on it. And, the resulting PVAD prototype that they made, they stick it into a bucket of water and it put a big rooster tail of water across the room, which kind of exhibits the pumping power that this crude prototype did. And as it's told to me, that video went on to key opinion leaders and fundraising people, and the rest is history. I guess the rooster tail was impressive.
That's impressive. How would one optimize the prototyping phases for both cost and speed?
Sure, Mark. Well, a couple things that Aaron mentioned about understanding what your key performance characteristics are and being able to really strongly communicate that to the resolution team, which is something that we can definitely help you with, as well as knowing how are we going to test this prototype. So Aaron kind of mentioned that this is a major question. It is, how do we know if you're meeting the requirements that have been put forth, right? And then thirdly is in the concept group, really limiting your interaction with our quality system and that kind of heavy documentation that is required to get all the way to the end goal. But doing that early when maybe you're low on funds or are trying to stay really lean, that does help us make progress very quickly.
So, in all these steps that take place, what are some of the realistic timelines for development, prototyping, and eventually production?
Yeah, development on a whole, I would say, again, it just depends on how much the customer understands their requirements. There's a lot of stuff the customer can do on the prep end to make this cycle shorter. But, concept, I wowould say 3 months you're looking at, to get maybe 3, 4 iterations, quick iterations to prove your concept out, to kind of get the design to maybe the 90% finished point. And then you go into formal development and you could be looking at maybe as quick as 6 months, maybe as much as 18 months, depending on the complexity of the device, the number of pieces that go into the system we're designing. And then, a lot of our customers, their endpoint would be clinicals, and which would kind of be at the end of that 18 months. Some of them go right into the 510K process and will go right into process valves. I would say the process valves could be 3 to 6 months, again, depending on the complexity of the device.
Aaron, what are some of the unexpected pitfalls that teams need to be aware of in this particular space?
Yeah, I think for me, what I've observed is a lot of times scope creep or just definition of the program, the original scoping. Coming in, knowing your product requirements, knowing the difference between your nice to haves, your must haves. If you spend too much time chasing, the nice to haves and not focusing on the must haves, I've seen a lot of, timeline lost, a lot of money spent, only to come back, when you get to design verification and you're like, okay, I guess I really didn't need it to be that. It could be this lesser extent. And to me, I think if to summarize it up, that would be what I've observed the most.
Kate, how do you know when you're ready to move on to the next steps of development?
So that's when I would refer to our stage gate system. So the second gate is a planning gate, concept is the first gate, and then you would move to design freeze and then execute DV in gates 3 and 4. So when you're looking at when is a customer ready to move from concept to planning, they have a good proof of concept, they've proven out feasibility, understand a little bit more about their procedure or refined that device a little bit. And then the next step, like I said, is that planning gate. And we were realizing, all right, now it's time to come to the table and look at, what are my next milestones and how I'm really going to plan the full execution of the project.
Now, there's a lot of sensitive material, I'm sure, that goes on at Resolution Medical when dealing with customers. So who retains the ownership property of the device design or the intellectual property?
Yeah, Resolution was set up by the founders this was a big topic, and it was just full transparency. The customer owns all IP, whether that be generated on the design side or the process side. We love to help create that IP. We'd love if the customers would put our engineer's name on it. Engineers like to have their names on patents, but just from a legal standpoint, from a financial standpoint, our customer free and clear has all the IP.
What's the best way to simulate real-world conditions to ensure reliability and safety?
Yeah, so this goes all the way back to when you're building your parts for design verification testing. You would put them through all the normal preconditioning. You would sterilize them 1-2 times. You would send them out to environmental conditioning and transit simulation to simulate basically the shipping process, the storage on the shelf process. You would accelerate age or real-time age them to establish a shelf life to prove that the product still functions as intended after that duration. Then when you get the product back and you're going through your design verification and shelf life testing, you want to simulate test methods that replicate real world conditions. A lot of times that would be making sure you have a body temperature water bath that you're doing your performance testing in. You would have anatomical vasculature simulation that would simulate the path to get to where you're delivering your therapy. You want to simulate the bends. You want to make sure your device can be delivered. You don't want to just stick it in a big straight tube in an open bath. I think that that's basically what we would do.
What kinds of teams are the right fit for Resolution Medical?
So Resolution is well equipped to handle both projects large and small. I think the true test of fit is actually we're looking for customers who want to be partners with us and really integrate into, have us integrate into their teams.
And what's it like to work with Resolution Medical?
Collaborative, transparent, true extension of your business, I think is the best way to put it. We will a la carte the experience if we need to. If you have 90% of what you need covered, we can add that last 10%. We have a very diverse skill set here. It could be you're working on the delivery, or maybe your implant. Your company is focused on the implant of a device and you need a delivery system, or vice versa. We have an implant department here. Maybe you need us 10 people 1 month. Maybe you need 1 person the next month. We have the ability to flex up and down depending on how your funding, your project success is going. Maybe you need just consultation, advice on how to pursue a regulatory path. We're trying to be whatever you need, when you need it.
Fantastic. Well, I want to thank you both for joining us today and providing a little insight into the concept development group at Resolution Medical. Appreciate it.
For sure.
Thanks, Mark.